In this video, we're going to look at the sine rule and the cosine rule. We use the rules to find missing lengths and angles in non-right angle triangles. So in the past, when we've dealt with a right angle triangle, to find a missing length or angle, we've used trig ratios, or if you like, SOHCAHTOA. So here's a right angle triangle, here's the angle, which I will say is theta. We've got now a right angle just here. Relative to the angle, this is the opposite. Relative to the angle, this is the adjacent. And relative to the angle, this is the hypotenuse. We saw the trig ratio sine theta, that was equal to the opposite over the hypotenuse. Cos theta, or the cosine of the angle, was the adjacent over the hypotenuse. And tan theta, or the tangent of the angle, was the opposite over the adjacent. We might have written that out as SOH, then we would have had CAH, and then we would have had TOA. And you might have remembered this by using a mnemonic. So one example could be, some old hags can't always hide their old age. So that's an example now of when we're looking to find missing lengths or angles in a right angle triangle. In the video, we're going to focus on non-right angle triangles. We decide which of the rules we're going to use based on the information we're given and what we're looking to find out. There are going to be 4 scenarios, and what I'm going to do is now draw them up here. So I'm going to split the page up into 4. So let's go ahead and do that. We'll start with the cosine rule. We're going to use the cosine rule to find missing lengths and missing angles. So what we'll do then is start now for the cosine rule, and we will have now, this will be used to find a missing length. Now, we use the cosine rule if we have an enclosed angle. So let's go ahead and look at an example of that. So here is a non-right angle triangle, and an example of an enclosed angle might be one here. If this is 95 degrees, we have, say, 12 here, and we have 13 here. The angle is enclosed between these two sides, and we can say that the missing side that we're looking for could be A. So we use the cosine rule to find a missing length when we have an enclosed angle. This works for both radians and degrees. So when you come on to radians, you can use exactly the same formula. So what I'm going to do now is just sketch this up. So what we would have here, and we will say that this angle is going to be big A, therefore the corresponding side is going to be A. I'll say that this one is going to be B, therefore the corresponding angle will be big B. This is going to be C, and then the corresponding side will be C. We can say that the cosine rule is A squared is equal to B squared plus C squared minus 2BC cos A. So that now gives us the cosine rule for a missing length in a non-right angle triangle. So if you're unsure, you're looking for an enclosed angle. Okay, so if we did this one right here, what we could say is A is going to be the square root. So we've got A squared here. A would be the square root of B squared, which would be 12 squared, plus C squared, which would be 13 squared, minus 2 lots of B, which is 12, multiplied by C, which is 13, multiplied by the cosine of the angle, which is 95 degrees. So in the calculator, you would go ahead and plug that in, and that would give you now the missing length. It doesn't matter which you call B and C. We could have had C here and could have had B here. It's essential though we have A and A corresponding. So this is a cosine rule to find a missing length. The other scenario where we use the cosine rule is to find now a missing angle. So let's look at the missing angle. We use this now when we have 3 known sides. So the cosine rule kind of helps us out with the sine rule, because once we know that we don't need to use, or we can't use the cosine rule, we would go straight for the sine rule. So if I said now that this was going to be 10, this was going to be 11, and this one was going to be, let's just say that's 12, we might want to find this angle right here. What I'm going to say is that this will be angle A. So we use the cosine rule to find a missing angle when we're given 3 of the sides. So if we consider now that this is going to be A, this is going to be B, this is going to be C. We can simply adopt this particular formula, or we could rearrange it and say that cos A is going to be equal to B squared plus c squared minus now, and we're going to have the a squared, and that will all be over 2bc. So this now gives us cos a, and to find a we would simply now take the inverse cosine of both sides of the equation. So in this particular case we could say that a is going to be equal to the inverse cosine, and we're going to have now b squared. So that's going to be 10 squared plus c squared, which is 11 squared, minus a squared, which is going to be 12 squared, and we would divide that now, let's just move this down, we would divide that by 2 times by b times by c. So at this stage it's entirely up to you of whether you've written it in this form or you've rearranged it. So if we now just divide this by 2, then we can have b, then we can have c, and that will give us now the answer. Again, calculator in degrees mode if this was given in degrees, or you could of course use radians. Okay, so that's the cosine rule. So if we consider now what's left, when we have the sine rule for missing lengths, we're talking about now non-enclosed angles. So let's look at side lengths. So an example might be, let's go ahead, and what we would have now is the following. Let's draw a non-right angle triangle. So that's a non-right angle triangle. We'll make it look like a non-right angle triangle. And what we can say, of course it does work for right angle triangles, but we would use the trig ratios instead. So what we're going to have then, this is going to be angle A, this would be side length A, we would have now that this would side length B, this is going to be the angle B, this would be C, and we could say now that this is going to be big C. We could say now, using the sine rule, that the sine, and this can be written two different ways, we can have A over sine A is equal to B over sine B, which is going to be equal to C over sine C. You will only ever need to use two of these. You won't need to have all three. So let's look at an example of this, and all I'm going to do is sketch this up. So what I'm going to say then is the following. I'm going to have now, and in terms of our A, B and C, it really doesn't matter. Let's say that this is going to be 10. Let's say that this angle is going to be now 50 degrees. So let's put 50 degrees on. Let's say that this angle right here, let's say that's going to be 100 degrees, and we might want to find now the missing length. So this is going to be the missing length. We could call this C, or we could, let's just make that 10 a bit easier to see, we could call it whatever we wanted. We could call it X. Really doesn't matter. So let's go ahead, let's just put 10. And let's say that we want to find this one right here. In fact, we'll just call this A. It really doesn't matter. So we're trying to find A. What we could write is that A over now the sine of A, just consider this to be the opposite angle. The sine of 100 will be equal now to B over sine B, which will be 10 over the sine of 50 degrees. We make A the subject, so we could say that A was going to be 10 sine of 100 degrees divided by the sine of 50 degrees. And that will give us now the missing length. So that gives us A. So essentially what you're saying to yourself, have I got an enclosed angle? If I've got an enclosed angle, I'm going to use the cosine rule, or if I have three side lengths, I'm going to use the cosine rule. Everything else is going to be used by, or use, we're going to use the sine rule for this. So if we now look at the sine rule for a missing angle, all we'll have is exactly the same. But at this stage, to make our life slightly easier, we could say that sine A over A is going to be equal to sine B over B, which in turn is going to be equal to the sine of C over C. So if we look now, let's draw another example up, and the A, B and C, again, it really doesn't matter. So let's say we wanted to find this angle right here. Let's say that this is going to be A, and we'll say that this one, let's call this one now, let's say that this is going to be B, and we'll say that B is going to be a 50-degree angle. We would be given now the value of A. Let's say that this was going to be 12. And then this one right here, let's just make up some number. Let's say that that's going to be 13. And we wanted to find the value of A. We could say that sine A over A, which is 12, is equal to the sine of 50 degrees divided by 13. We would multiply both sides by 12, so sine A is going to be equal to 12 sine of 50 degrees divided by 13, and then we could say that A was equal to the inverse sine of 12 sine of 50 degrees divided by 13. So that would give us A. So all you're saying to yourself now, when you're given a situation, what information have I got? What information am I looking to find? I always work straight from the cosine rule and then establish whether I've got now an enclosed angle of 3 sides. If not, we go for the sine rule. What we're going to do is look at a brief proof of each of these. So if we start now with the cosine rule, let's go ahead and look at the cosine rule. We'll write it just here. What I'm going to do now is draw a non-right angle triangle, and we're going to drop a perpendicular down. So what we're going to have then, let's look at something like so. So what we'll have now is this scenario. I'm going to drop this perpendicular down, and this is going to have height. Now, let's just say that height is going to be h. So this height right here is going to be h. So let's just put the right angle here. That is h. Let's go ahead and label up some angles. We could say that this is going to be the angle C. Therefore, this length is going to be C. If we said that this was going to be angle A, then this one right here is going to be now the size A. So, or the length A, we could say. This is going to be the angle B, and this will be the side length B. What I'm going to do is just write D here. D is going to be now the foot of the perpendicular. I'm going to say that this length is going to be x, therefore this is going to be C minus x. So if we just think about this now, this total length right here, AB is going to be the length C. All I've done is split this up, x, and then we're going to have C minus x. Let's consider now a couple of different right angle triangles. So if we look at this right angle triangle here, we've got the triangle now ACD. So if we just look at ACD, we can make a couple of statements from this. We can state now that the cosine of A, if we just write this down, cos of A is going to be equal to x over b. So if we write this down, we can say that x is equal to b cos A. So let's write this here. So x will be equal to b cos A. If we now consider in the same triangle right here, we can see using Pythagoras that now x squared plus h squared will be equal to b squared. So we can write that down. We can say from here now that b squared will be equal to x squared plus now h squared. And that's just using basic Pythagoras. If we now consider this triangle right here, what we've got is another right angle triangle. This triangle is going to be BCD. So the first one was ACD, this is going to be BCD. Again, if we use here Pythagoras, we can say from here that a squared is going to be equal to c minus x squared plus h squared. So what we're going to have is c minus x, which we're going to square, plus now the h squared. If we expand this out, we're going to get a squared will be equal to c squared, then we'll have minus 2cx, or xc, and then we're going to have now plus x squared plus h squared. If we consider, we already have now an expression for x squared plus h squared. So we can substitute this in. So if you like, you can go ahead and call these equation 1 or equation 2. All I'm going to do is sub this in. So what we'll have then is a squared is going to be equal to c squared, then we're going to have minus 2xc, or cx, plus now b squared. If we think about what we have here, we can just tidy this up and we can write that a squared is equal to b squared plus c squared minus 2, and then what we have here is c multiplied by x. We already have now an expression for x, and that's going to be b cos A. So all I've written now is that a squared is going to be equal to b squared plus c squared minus 2bc cos A. So we can see how using basic right angle trig and Pythagoras has allowed us now to show the cosine rule. As stated, if you want to be slightly more formal with this, you can call these simultaneous equations. If you want, you can call this one equation 1, this one equation 2, and sub it in. All I've done is considered now two different right angle triangles, used trig ratios and Pythagoras, and then made substitutions to show now that a squared will be equal to b squared plus c squared minus 2bc cos a. So that's showing the cosine rule. Now we could show the sine rule. The sine rule is slightly easier. So let's have a look at the sine rule now. So if we take now the sine rule, so let's just jot this here and we'll write this down. What I'm going to do is another triangle and we're going to drop a perpendicular down. So here is my triangle and let's just extend that. Let's have something that looks like that. There we go. So what I'm going to have then is now a height, and this is going to be the perpendicular, and we're going to again split this into two right angle triangles. So what we'll say then, we'll say that this is going to be A, that'll be angle A, this will be now side A, this will be B, this will be side B, and this is going to be H. If we consider now the angle here, this is going to be C, and we could have this point right here. What we're going to look at are now these two triangles, and the first one I'm going to look at is triangle now ACD. If we think about this, we can state from here that the sine of A, and I'll write it just here, the sine of A, and just jotting it down, sine of A is the opposite over the hypotenuse, which is going to be H over B. If we look at the other triangle, and that is triangle BCD, what we have here is the sine of B, let's put sine of B is going to be now H over A. So if we do that one, we have H over A. Let's rearrange now and make H the subject in both cases. Now we could call this one equation 1 and equation 2. So what we could say at this stage now is that B sine A is equal to H, and in this one right here we could say now that A sine B is equal to H. Therefore, if H is equal to this expression, H is equal to that expression, B sine A is equal to A sine B. And at this stage now, we can simply divide both sides, and whichever way round you want to express it, you can divide both sides by sine A, both sides by sine B, and we'll have now that A over sine A will be equal now to B over sine B, or you could invert those fractions. Quite clearly we could show again that holds for C if we drew a different perpendicular and considered now C relative to the other angles. But essentially that's now just a quick demonstration of why and how the sine rule works. You won't be asked to replicate those, but I think it's interesting nonetheless. So there we go. A over sine A is equal to B over sine B, which is equal to C over sine C. You will only ever use two of them, and you don't need to label them up A, B and C. You can have X, Y and some numeric values. Okay, let's move on now and look at some different triangles. What we're going to do is just work through these and decide now which of the particular rules we would use to find a given angle or length. So let's look at this one right here. What we have now is three given sides, and we would find an angle. So we could find this angle, we could find this angle, or we could find this angle. So we would use the cosine rule now for a missing angle. So three sides and we want an enclosed angle, we'd use the cosine. This one we would use the cosine rule now to find this missing length, which is km. We have an enclosed angle and two sides. So cosine rule to find a missing length. If we look at this one right here, now we have a non-enclosed angle, two given sides and this angle. So what we could do is go ahead and use the sine rule to find a missing angle. We could say now that this angle right here, sine A over 25, will be equal to the sine of 72 over 47. If we wanted to find this one, we would simply subtract these two away once we found this angle from 180 degrees. If we look at this one right here, we would use now the sine rule to find a missing length, and that would be now the length f to g. We've got an angle, we've got another angle, and then we've got one side length. So I could call this x right here, and I could now say that x over sine of 78 is equal to 29 over sine of 43, and go ahead and solve. This one, we would use the cosine rule to find the missing length, and that would be uv or vu. This one would be the cosine rule to find a missing angle, as we're given 3 lengths. This one right here, we would use the sine rule to find a missing angle, as we're given 2 sides and a non-enclosed angle. This one right here, we would use the sine rule and we would find a missing angle. We've got one angle, we've got 2 side lengths, and this is a non-enclosed angle. This one right here, we would use now the cosine on this one, sorry, on the sine rule on this one to find now a missing length, and that missing length would be here. So if we wanted x, this would be the sine rule for a missing length. This one would be the cosine rule for the missing length, and that missing length is going to be xy or yx. We have an enclosed angle and 2 of the side lengths. This one right here, cosine rule for a missing angle. So we could find that one, we could find that one, or we could find that one. Again, cosine rule for a missing angle. This one right here, cosine rule for a missing angle. Here we would have now the cosine rule for a missing length, and that length would be PQ, as we've got an enclosed angle and 2 sides. We'd have this one right here, this would be the cosine again for a missing length, and then that would be now the length right here, ML, as we've got the enclosed angle and 2 given sides. This one right here, we would now find a missing angle using the sine rule. We've got now our angle, 2 sides, and it's a non-enclosed angle. Okay, so that now is choosing which one to use. Let's go ahead and calculate some of these, and we're going to work through some basic examples in degrees. So we're asked to calculate the sizes of the unknown value of x in each of the following triangles. So if we look at this one right here, x is here. What we're trying to do is find an angle given 3 side lengths. So what we can use is the cosine rule. So we can say in general, cos A is equal to b squared plus c squared minus a squared over 2bc. If you want to use the original cosine rule that hasn't been rearranged, you're more than welcome to do that. It just means a bit of rearranging at the end. So what we can say then is A will be equal to the inverse cosine. And in this particular case, in fact, let's just call this x, as that is what we're doing. X is going to be equal to the inverse cosine. So let's pop that on. And what we're going to have now, the inverse cosine of 9 squared plus 11 squared minus 12 squared over now 2 lots of 9 multiplied by 11. So all we've done is gone ahead now and simply plugged that in. So in a calculator, in degrees mode, shift mode 3, what we're going to have is the following. We're going to do the inverse cosine. Now, if this isn't an exam, do find out how much working you need to show. Sometimes you'll have to write out the numeric value of each of these. I personally find it easier just to sub it straight for a calculator, but again, depending on what you're meant to show, we'll just go ahead and sub that in. So if we just look at this, we can say now that A is going to, and we just call this A is going to be the inverse cosine of b squared plus c squared minus a squared all over 2 times by b times by c. So straight for the calculator with this, and that's going to give me 72.96. So I'm going to say that x is going to be equal to 73.0. So we've got now x is equal to 73.0 degrees, and that now is given to 1 dp. So does that look like a 73-degree angle? Well, let's just say our answer come up to be 148. Quite clearly, that is not going to be the case. So it'd be fair to now think that that's a pretty fair approximation. Okay, let's choose another one. Let's find now a missing angle. So we've got a non-enclosed angle and 2 sides. So what I'm going to use is use the sine rule. So what we could say is sine A over A is equal to the sine of B over B. So in this particular case, I'm going to say now that the sine of x over 16 will be equal to the sine of 37 over 11. So multiplying both sides by 16, we can say now that x will be equal to the inverse sine of 16 lots of a sine of 37 over 11. Straight for a calculator, and then we'll round our answer. So what we'll have then is the inverse sine, and we're going to have now 16 sine of 37, and we're going to divide that now by 11. So if we do that, we can now get that value, and that will give us 61.1. So to one decimal place, x will be equal to 61.1 degrees, and that's just as one decimal place. So does that look reasonable? Well, pretty much so. It looks okay. Right, let's have a look at another one. Let's go for this one. So what we've got on the next one here is a missing length, but we have here an enclosed angle on two sides. So this will be the cosine rule. So in general, we can say a squared will be equal to b squared plus c squared minus 2bc cos a. So we can say that x will be equal to the square root. So x squared, I could write it out. We're going to have 5.2 squared plus 4.5 squared minus 2 lots of 5.2 multiplied by 4.5 multiplied by the cosine of the enclosed angle where the angle is given in degrees. So cos of 58. So straight for a calculator, let's go ahead and do that. So what we'll have then is the square root of 5.2 squared plus 4.5 squared. Then we'll have now minus, and we can write this as 2 times by 5.2 times by 4.5 times by now the cosine, and the cosine of the angle that we've got in degrees as 58 degrees. So if we go ahead and do that, let's bracket all of that off. We end up now with 4.74. So I'll do this one to two decimal places. Let's say x will be equal to 4.74. And that's going to be now in meters, and that is given now to 2dp. You'll be given a level of accuracy. If not, generally 3 significant figures or 2 decimal places is usually okay. Now they've given this in terms of 1 decimal place. The level of accuracy should at least match this. So stating it's 5 would not really be suitable. Okay, so that now gives us the cosine rule for a missing length. Let's look at one more. Let's do this one. So what we have is a missing length. We're given a length and 2 angles. So for this one, we can use the sine rule. We can say that a over the sine of a is equal to the b over the sine of b. So in this particular case, we can say now on here that x over the sine of 43, that now is the opposite angle to x, will now be equal to the following. So if we consider what we have here, we're going to have 14, and I'm going to write this as 14 over now the sine of this angle right here. Now if we think about this, we haven't got the angle here, but quite clearly if I add these up, we've got now 72 and 43. So if I add those, that's going to give me 115. So this is going to be now 65 degrees. We know that the angles in a triangle equal to 180, so we can now write this as the sine. Let's write this in, the sine of 65. So if we just put this in, sine of 65, so we can now write that x, we're making x the subject, is 14 sine of 43 divided by the sine of 65 degrees, and straight through a calculator with that. So all we've got now, let's go ahead and do that. So 14 sine of 43, so let's put this in, and then we're going to divide this now by the sine of 65 degrees. Let's just check I've got all of that incorrect. So 72, 43, 115, 65, that looks perfectly fine. 10.53 and so on and so forth. So we'll say that x is going to be equal to 10.5. So x is going to be 10.5, and that will be meters. Again, we'll be given a level of accuracy to shoot for. I'm not too interested in that. I just want to get an idea now of the workings. So that gives us now a brief insight to the cosine rule and the sine rule. So let's just recap. What we've got here now is a missing angle, and we've got 3 known side lengths. cosine rule for the angle. This one here, we have two side lengths and a non-enclosed angle, and we want to find the other angle. So that would be the sine rule. Here we have an enclosed angle and two side lengths. We would use the cosine rule for the missing length. Here we have an angle and we have a non-enclosed angle and two given side lengths, so we'd use the sine rule. Here we've got two side lengths and we've got now a non-enclosed angle just here, and we would be looking to find this one right here. And then finally we have now two angles, so we've got our two angles. That's a non-enclosed angle essentially, and then we're looking to find a missing length, and we were working this angle out first. So there we go. That's a brief introduction to the sine and the cosine rule, and we use those as stated to find missing angles and lengths in non-right angle triangles.